Hello again, Algebra 2. Here's the continuation of Section 6 of Chapter 1, solving compound and absolute value inequalities. Sorry about that. So we did this in the first video, and let's continue to the second page of your guided notes. We're going to start with example 4. So, same directions. I need to solve the inequality, graph the solution on a number line, and write the solution in interval notation. So let's take a look at this one. This one is actually here because it is a trick question. Think about this. Don't get lost in the algebra, just think about this. The absolute value of u is greater than -2. Well, what do you know about absolute value? It's always positive. So this right here is always true. Any number you put in there, absolute value will be greater than -2 because it's always positive. Therefore, your solution is all real numbers. How do you graph that on a number line? You shade the whole number line. All of it. All real numbers. How do you write that in interval notation? You say I can be as low as -infinity and as high as +infinity. That is all of the numbers, all of the answers. There we go. Let's go more to one that's a little more interesting, a little more complicated. Here we go, example 5. Following what we did in example 3, I need to split this into two separate situations. I have the expression in the absolute value bar could be greater than or equal to 13. Or I could have the expression in the absolute value bars being less than or equal to -13. Switch the inequality symbol, switch the sign. Those are your two options here. And we're going to solve both of these. So here we go. I'm going to add 5. I'll do one at a time here. We have 6y now is greater than or equal to 18. I divide by 6. I get y must be greater than or equal to 3. So that's the first branch that I'm dealing with. Now, notice the steps are going to be very similar over here. I'm going to add 5. So I have 6y is less than or equal to. Now I am dealing with -8. -13 plus 5, I have -8. When I divide by 6, again, I'm going to get a slightly different answer than over here. I get y is less than or equal to, and I'm going to go to my calculator to get the correct decimal. I have -8 divided by 6. I get -1.3 repeating. -1.3 repeating. So these are my two branches. So again, notice I cannot be both of these things. There is no y value that is both. So this is an or situation. So this is a union. I can have them both separately, and in this problem we're going to have them together, but I cannot actually have a y value that is both at the same time. So first, graphing this on a number line, my important values are -1.3 repeating and +3. I can be greater than or equal to 3. So equal to, I have my filled in dot, greater than -1.3. Since it's less than or equal to, I have a filled in dot. Less than, I'm going to the left. How do I write this in interval notation? I'm going to start at my leftmost endpoint, which is -infinity, go all the way up to -1.3 repeating. I am allowed to use -1.3 repeating, so it gets a bracket. Then I'm going to put the union of, I can start my second branch, I am allowed to use 3, so a bracket with 3, all the way up to +infinity, parenthesis on that. So there is your inequality solution, your number line version, and your interval notation version. Now, let's go to a word problem, just to see how we could work with this. And I want to show you a technique you can use to work with these. So here we go. Rachel is considering colleges to attend and determines that the average tuition among her choices is $3,725 per year. But the tuition at a school could differ by as much as $1,650 from the average. Write and solve an absolute value inequality and find the range of the tuition. Now, we know that this could be solved a lot easier. You just take the 3,725, add and subtract 1,650. But I want to show you a technique to use to solve equations like this, inequalities like this, just in case it's a more complicated situation if there's more than just single numbers involved. So here we go. We know that the difference from the highest school or the lowest school from the average, so from 3,725, I could be above or below by 1650. Now, that 1650 is positive, even though if it was lower, if the original tuition was lower than 3,725, if I subtract it, I would get a negative number, but they've given me this positive number as the difference. So that's where absolute value comes into play. So how we are going to write this, we are going to set a variable, let's say T is the tuition at any given school. So depending on where she's looking, she can just plug in the tuition into this equation. We are going to say that whatever the tuition is, minus the 3,725. When I do that subtraction, if I make it positive, in this case that is all the absolute value bars are doing for us, making this a positive number, the difference here is going to fall within this 1,650 range, meaning my difference here is less than or equal to 1,650. There we go. So take the tuition, subtract the average from it, and that's going to be the range, less than or equal to the range on either side. So that's us writing the inequality. Now let's solve the inequality to get the range. We are going to split this into two pieces like we've done before. So T minus 3,725 could be less than or equal to 1650, or T minus 3,725 could be greater than or equal to negative 1,650. And we're going to solve both of these. So over here, I'm going to add that 3,725 to both sides. I'm just going to go to my calculator quick, make sure I don't do the wrong number. We have 1650 plus 3,725. I get 5,375. 5,375. T is less than or equal to 5,375. And then over on the other side, I'm going to add the same 3,725, but this time I'm working with a negative 1650. So I have negative 1650 plus 3,725. 2,075 in this case. 2,075. So her range in tuitions is from 2,075, that is inclusive, I am allowed to have that number, all the way up to 5,375. That's how we would write it in interval notation, and that is fine. It doesn't really tell us what to do, it just says solve it, so I can write my answer like that. So that is the range of tuitions that she is looking at. So that is the end of section 6, all about solving compound and absolute value inequalities. Again, this problem itself could have been solved a lot quicker just by adding and subtracting 1,650, but this is a good pattern to use to solve more complicated problems. Remember the 1650, this was the range or the difference in the situation, and the 3,725 is more of the core value, the average that was used. So that's a good system to go by. So there is section 6, and we will talk about this more in class.